Good morning to all. I am Dr.S.THAIYALNAYAKI, Assistant Professor of Computer Science, A.D.M. College for Women, Autonomous, Nagapattinam. Now we see about the advanced Java programming for PG students. First of all, we see about the Java and then continue from advanced Java. Java is a widely used object-oriented programming language and software platform that runs on billions of devices, including notebook computers, mobile devices, gaming consoles, medical devices, and many others. The rules and syntax of Java are based on C and C++ languages. One of the major advantages of developing software with Java is its portability. Once you have been written code for a Java program on a notebook computer, it is very easy to move the code to mobile device. When the language was invented in 1991 by James Gosling of Sun Microsystems, later it occurred by Oracle, the primary goal was to be able to write once and run anywhere. It is also important to understand that Java is much different from JavaScript. JavaScript does not need to be compiled, while Java code does need to be compiled. Also, JavaScript only runs on web browsers, while Java can be run anywhere. Java's durability is impressive. More than 2 decades after its creation, Java is still the most popular language for application software development. Developers continue to choose it over languages such as Python, Ruby, PHP, Shift, C++, and others. As a result, Java remains an important requirement for competing in the job market. Java programming language is named Java. Why? After the name Oak, O-A-K, Oak, the team decided to give it to a new name to it. And the suggested words were silk, jolt, revolutionary, DNA, dynamic, etc. These all names were easy to spell and fun to say, but they all wanted the name to reflect the essence of technology. In accordance with James Gosling, Java, among the top names along with silk, and since Java was a unique name, so most of them preferred it. Java is the name of an island in Indonesia where the first coffee named Java coffee was produced, and this name was chosen by James Gosling while having coffee near his office. Note that Java is just a name, not an acronym. How Java works? Java is a technology. It consisting of both a programming language and a software platform. To create an application using Java, you need to download the Java Development Kit, that is JDK, which is available for Windows, Mac OS, and Linux. You write the program in the Java programming language, then a compiler turns the program into Java bytecode. The instruction set for the Java Virtual Machine, JVM, that is a part of the Java Runtime Environment, that is JRE. So Java bytecode runs without modification on any system that supports JVMs, allowing your Java code to be run anywhere. So the Java software platform consists of the JVM, the Java API, that is Application Programmable Interface, and a complete development environment. So the JVM parses and runs, that is interrupt the Java bytecode. Java API consists of an extensive set of libraries, including basic objects, networking, and security functions. Extensible markup language, that is XML generation and web services. Taken together, the Java language and the Java software platform create a powerful, proven technology for enterprise software development. Technical benefits. Already we see that when it comes to choosing a programming language and the environment for your next enterprise application, there are solid technical reasons to consider Java, including interoperability, scalability, and adaptability. The core philosophy behind its creation, interoperability across disparate devices. The core philosophy behind its creation, interoperability across disparate devices, remains the strongest argument for favoring Java for new enterprise applications. Java's object-oriented architecture allows you to create modular programs and reusable code, shortening development cycles and extending the longevity of enterprise applications. Platform scalability is a key attribute of Java. With Java, you can use one single system across a broad range of use cases. Existing desktop applications can be easily adapted to run on smaller devices that have limited resources. You can also migrate applications from one mobile to desktop computer, developing business apps for the Android platform and then integrating them into your current desktop software, bypassing lengthy and expensive development cycles. Java also wins points with strategic planners for its ability to adapt to new use cases. For example, Java is widely considered to be an ideal platform for the IoT, Internet of Things. The typical IoT application interconnect a large number of disparate devices, a task that is greatly simplified by the fact that billions of devices run Java. Furthermore, Java's extensive ecosystem of developers is constantly developing and sharing new libraries with the functionality specifically targeted at IoT application development. Next, Java terminology. Some of the keywords used in Java as follows. One is Java Virtual Machine, that is JVM. This is generally referred to as JVM. There are three execution phases of the program. They are written, compile, and run the program. Writing a program is done by a Java programmer like you and me. The compilation is done by the Java C compiler, which is a primary Java compiler included in the Java Development Kit JDK. It takes the Java program as input and generates bytecode as output. In the running phase of a program, JVM executes the bytecode generated by the compiler. Now we understood that the function of Java Virtual Machine is to execute the bytecode produced by the compiler. Every operating system, that is OS, has a different JVM, but the output they produce after the execution of the bytecode is the same across all the operating systems. This is why Java is known as a platform independent language. This is important concept in Java. And second one is bytecode. Bytecode in the development process. As discussed, the Java C compiler of JDK compiles the Java source code into bytecode so that it can be executed by JVM. It is saved as .class file by the compiler. To view the bytecode, a disassembler like Java P can be used. Next, third one is JDK, Java Development Kit. While we are using the term JDK, when we learn about bytecode and JVM, so as the name suggests, it is a complete Java development kit that includes everything including compiler, JRE, that is Java Runtime Environment, Java Debugger, Java Documents, etc. For the program to execute in Java, we need to install JDK on our computer in order to create, compile and run the Java program. Next, fourth one is JRE, Java Runtime Environment. JDK includes JRE. JRE installation on our computers allows the Java program to run. However, we cannot compile it. JRE includes a browser, JVM, applet support and plugins for running the Java program. A computer needs JRE. And next, fifth one is garbage collector. In Java, programmers cannot delete the objects. To delete or recollect that memory, JVM has a program called Java Garbage Collector. Garbage collectors can recollect the objects that are not referenced. So Java makes the life of a programmer easy by handling memory management. However, programmers should be careful about that code, whether they are using objects that have been used for a long time. Because garbage cannot recover the memory of objects being referenced. Next, sixth one is class path. The class path is the file path where the Java runtime and Java compiler look for .class files to load. By default, JDK provides many libraries. If you want to include external libraries, they should be added to the class path. Next, primary and main features. Primary or main features of Java. First one is platform independent. Why we call it is a platform independent. Compiler converts source code to bytecode and then the JVM executes the bytecode generated by a compiler. This bytecode can run on any platform, be it Windows, Linux or Mac OS. Which means if we compile a program on Windows, then we can run it on Linux and vice versa. Each operating system has a different JVM, but the output produced by all the OS is the same after the execution of the bytecode. That is why we call Java is a platform independent language. And second is Java is a object oriented programming language. Why we call it is a object oriented programming language. Organizing the program in the terms of a collection of objects is a way of object oriented programming, each of which represents an instance of the class. The four main concepts of object oriented programming are, that is, Wolf's concepts are abstraction, encapsulation, inheritance and polymorphism. And then third one, simple. Why we call it as a simple? Java is a simple program, simple one. Java is one of the simple language as it does not have any complex features like pointers, operator overloading, multiple inheritance and explicit memory allocation. There is any disadvantages or any difficulties or any complex in by using Java. Next, fourth one is robust. Java language is robust, which means reliable. It is developed in such a way that it puts a lot of effort into checking errors as early as possible. That is why the Java compiler is able to detect even those errors that are not easy to detect by another programming language. The main features of Java that make it robust are garbage collection, exception handling and memory allocation. Next one is fifth, secure. Why we call it as secure? In Java, we do not have any pointers, so we cannot access out of bound arrays. That is, it shows array index out of bound exception. If we try to do so, that's why several security flaws like stack corruption or buffer overflow are impossible to exploit in Java. Also, Java programs run in an environment that is independent of the operating system environment, which makes Java programs more secure. And sixth one is distributed. Why we call it as distributed Java? We can create distributed applications using the Java programming language, remote method invocation, that is RMI, and enterprise Java beans, that is EJB, are used for creating distributed applications in Java. The Java programs can be easily distributed on one or more systems that are connected to each other through an internet connection. And seventh one is multi-threading. Java supports multi-threading. It is a Java feature that allows concurrent execution of two or more parts of a program for maximum utilization of the CPU. Next one is portable. Why we call it as portable? As we know, Java code written on one machine can be run on another any machines. The platform independent feature of Java, in which its platform independent bytecode can be taken to any platform for execution, makes Java portable. And next one is high performance. Java architecture is defined in such a way that it reduces overhead during the runtime, and at sometimes Java uses just-in-time, that is JIT, just-in-time compiler, where the compiler compiles the code on demand basis, where it only compiles those methods that are called, making applications to execute faster. And next one is dynamic flexibility. Java, being completely object-oriented, gives us the flexibility to add classes, new methods, and to existing classes, and even create new classes through subclasses. Java even supports functions written in other languages such as C, C++, which are referred to as a native methods. And next one is sandbox execution. Java programs run in a separate space that allows user to execute their application without affecting the underlying system with the help of a bytecode verifier. Bytecode verifier also provides additional security, as its role is to check the code for any violation to access. And next one is write once, run anywhere. As discussed above, Java application generates a .class file that corresponds to our application, that is program, but contains code in binary format. It provides ease to architecture neutral case, as bytecode is not dependent on any machine architecture. It is the primary reason Java is used in the enterprise in IT industry globally, worldwide. And next one is power of compilation and interpretation. Most languages are designed with the purpose of either they are compiled language or they are interpreted language. But Java integrates, arising enormous power as Java compiler compiles the source code to bytecode, and JVM executes this bytecode to machine operating system dependent executable code. Next, class. Class keyword is used to declare classes in Java. And public. It is an access specifier. Public means this function is visible to all. Next, static. Static is again a keyword used to make a function static. To execute a static function, we do not have to create an object of the class. Next, the main method here is called by JVM without creating any object for class. Next keyword is void. It is in return type, meaning this function will not return anything. Next, main. Main method is the most important method in a Java program. This is the method which is executed, hence all the logic must be inside the main method. If a Java class is not having a main method, it causes compilation error. And next one is string args method. This is used to signify that the user may opt to enter parameters to the Java program at command line. We can use both string args method or string args square bracket. That's it, string args method. Java compiler would accept both of the forms. And another one is system.out.println. This is used to print anything on the console like printf in C language. Okay, that's all about the Java. Now we see about the advanced Java. What is meant by advanced Java? In the area of coding, creativity and state-of-the-art technology have a vital role in the domain of software creation. Java is known for its platform independence, robustness, and extensive libraries. Advanced Java concepts let you make really complicated programs. It encompasses an array of technologies, libraries, and various frameworks that are beyond the fundamental principles of core Java. Advanced Java is the collection of technologies and tools that enable developers to create dynamic and secure applications, including features such as JDBC, that is Java Database Connectivity, servlets, and JSP, Java Server Page, are being used for generating and making interactive dynamic content. The most important feature of advanced Java is JPA, that is Java Persistence API, that is used for managing relational databases. Spring framework that encompasses the modules for dependency injection, Spring MVC framework, and AOP, aspect oriented programming, and Spring security that ensures the authentication and authorization of the applications. Next, fundamentals for learning advanced Java. To learn advanced Java, it's important to understand prerequisites thoroughly before deep diving into the more complex topics. As basics will provide a strong foundation for Java. Following are some key prerequisites. First one is core Java proficiency, and second OOPS concept, object-oriented programming, and third one is web development basics, fourth database fundamentals, and fifth Java standard libraries and basic programming logic, and last one is understanding of networking. So Java techies, keep in mind that becoming proficient in advanced Java is a step-by-step journey, so take your time to fully grasp each condition. The basics serve as the solid fundamentals that will help developers to handle the complexities of advanced Java. Advantages of advanced Java. There are certain advantages of advanced Java are mentioned below. Advanced Java has some following advantages with great quality and capabilities which enhance your Java application. Advanced Java creates dynamic web applications with tools like servlets and JSP. It gives scalability for your big Java projects with the enterprise Java builds, that is EJP, so that smoothly your Java application can develop and scale up to handle large workloads. Having efficient data management with the database connectivity, JDBC. It gives reusability of code, and with such advanced frameworks like Spring that also promotes modular design and makes your code base more organized. Advanced Java supports integration of web services by providing robust security and fast development process. We see some of the technologies, that is components used in advanced Java. Just what here we see it. First one is Java Enterprise Edition, that is shortly we call Java EE. Java Enterprise Edition. Now we call as Jakarta EE. It's a remarkable component of advanced Java programming. It gives scalability for big league applications that provide a smooth pattern to create applications that could grow seamlessly as your user base expands. Basically, it's designed to help developers create powerful, scalable, and robust enterprise level applications. And second one is Java Servlet in Java EE. Java Servlet or the magic behind the scenes of the web applications in advanced Java. It's used to create dynamic and interactive web pages. Servlets create web dynamic pages have the great feature for user interaction that quickly creates response that match your actions. Servlets act as a fast messenger between your web browser and servlet. Servlet manages users' request and response. As the servlet receives users' request, it processes and sends back a adapted response in an instant to the users, all in the blink of an eye. Next one is JSP, Java Server Page. JSP stands for Java Server Page. It is used to build web applications that are more interesting. JSP creates the web pages that can change and adapt as per the user command, like what user is giving input and dynamically adjust according to the user input that renders the dynamic content. JSP efficiently integrates Java into HTML pages where you have an option to convert any pre-existing HTML pages by modifying its extension to .jsp instead of .html. JSP reduces the length of your code and makes it easy to maintain without having the need of redeployment and recompilation as its platform independent. And next one is JSF, Java Server Faces. It encompasses a collection of APIs, that is application programmable interfaces, that simplify and streamline web pages, user-friendly and interactive. JSF uses a building block method where developers can pick and arrange UI components like buttons, forms and tables to create complete web pages. JSP abstracts the complexity of web development by encapsulating the intricate behaviors and allowing developers to focus on combining UI components. JSF operates on servers as well, processing user interactions and generates the appropriate content to render. It gives seamless integration in advanced Java and assemble dynamic event-driven and user-friendly enterprises. And next one is Enterprise Java Beans, that is EJB. It's a specialized component that handle complex business logics and process in advanced Java. They manage scalability, secure transactions, and efficient data processing that could tackle complex business tasks. EJB ensures that your data is saved correctly, and if something goes wrong, it undo the modification to maintain overall consistency. Also, EJB executes tasks in the correct sequence. EJB works in an unfeed system as it follows applications to distribute among different computers. It has control over who can have access to the application and ensures security guards by protecting data that keeps unauthorized users out. EJB manages complex logic, handles transactions, and ensures scalability. By using EJB, it creates powerful business software. And next, in advanced Java, we have concurrency. Concurrency having the ability in advanced Java to execute multiple tasks simultaneously that runs independently and concurrently by allowing different programs. Concurrency plays an important role as it maximizes the performance, enhance responsiveness. In simpler terms, concurrency implements multiple tasks at once. It has the synchronization that prevents the data corruption and race conditions and deadlocks. Concurrency is vital in modern software development, where Java provides thread-safe collections like concurrent map and concurrent queue that are accessed by multiple threads concurrently. Example, ticket booking. Imagine you are a developer and designing an online ticket booking functionality where many users are trying to book tickets concurrently and your aim is to guarantee a seamless booking encounter for the respective users. And another concept is multi-threading. Multi-threading is the process of having several tasks running together parallelly within the same program. It improves the responsiveness to keep users' interface responsive by saving the time while performing time-consuming tasks in the background simultaneously. That divides a large task into smaller parts that could run concurrently. Multi-threading has Java API features that creates and manages thread easily. In advanced Java, by using multi-threading in applications, developers can create more fast, secure, responsive and capable so that could handle complex tasks efficiently. And another one is JDBC. It stands for Java Database Connectivity, which is very essential component in advanced Java for interacting with databases. It connects with various relational databases that executes the queries and manipulates the data with the help of Java APIs. JDBC allows the Java program to interact with the database to retrieve information, store the data and update the data. In order to overcome the problems by using JDBC directly, Spring Framework has provided one abstraction layer on top of existing JDBC technology. We used to call this layer as Spring JDBC. Following are the step-by-step connection of JDBC. First one, load the JDBC driver. Already in programs we use it, class.forName. In method we use double quote com.mysql.cj.jdbc.driver, double quote close the parenthesis and semicolon. And second one is establish a connection. Next one is Java Persistence API, JPA. It's a collection of classes in Java Persistence API. Collection of classes not only have a methods to persist or store the vast amount of data into a database. JPA is a specification to store or manage Java objects or classes into the databases, which use Object Relational Mapping (ORM) as implementation internally to persist the database. JPA Persistence Framework needs to follow Spring Data JPA and Spring Repository. First one is Spring Data JPA. Spring Data JPA provides a higher level abstraction layer on the top of JPA that reduces the amount of boilerplate code needed for common database operations. And another one is Spring Repository. It is a JPA specific extension for repository. It has full API CRUD repository, also the paging and sorting repository. So basically the JPA repository contains APIs for basic CRUD operations, the APIs for pagination and the APIs of sorting. And next one is Spring Framework. Aims to overcome the application problems by enabling the use of simple Java beans to implement the business logic, enable the developers to create and test the application very easily, and then aims to minimize the dependency of application code on its framework and enables the use of simplicity and ease of testability in standard application. The Spring Framework has a layered architecture made up of several well-defined modules and then features of Spring Framework. Pluggability. It allows us to associate and remove business layer objects with each other with the help of configuration files. Spring requires you to make changes in the XML configuration file and run the application again to take effect. And second one is dependency injection. It allows you to lose coupling by creating the business layer objects based on the description in the Spring configuration file. As a result, it eases the maintenance and testing of an application. And container is the third feature. The Spring Framework is a container that holds all the application objects. It is responsible for managing the lifecycle and configuration of all the application objects. The container creates objects which are defined in configuration files and associate them together. And fourth one is lightweight. Spring is a lightweight framework that makes it easy to configure and create complex applications. It consists of several well-defined modules built upon the concept of DI. And the next one is Spring Framework provides two types of container. First one is Bean Factory. It's a simple container that provides support of DI. And second one is application context is built upon the concept of bean factory container and provides other functionalities such as AOP and internationalization. And the next one is Hibernate. Hibernate is a Java persistence framework. Persistence is the availability of the object or data. Even after the process that created it, it is terminated. There are 4 layers in the Hibernate architecture. First one is Java application layer, and second one is Hibernate framework layer, and third one is backend API layer, and fourth one is database layer. For creating the first application, we need to know the elements of Hibernate architecture. They are as follows. First one is session factory. Session factory is a factory of session and client of connection provider. It holds a second level cache, that is optional data. This provides a factory method to obtain a session object. In this, we have a session. The session object provides an interface between the application and data stored in the database. It holds the first level cache mandatory of data. And Java applications can use the Hibernate framework as the persistence layer for storing and retrieving plain old Java objects to or from a relational database. Hibernate is a persistence framework that provides tools for object relational mapping, that is ORM, object relational mapping. In that we have used one. First one is load. In load method, it takes a class object and load the state into a newly instantiated instance of that class in persistent state. It throws an unrecoverable exception. And next, second one is get method. Use get method if you are not sure that our matching row exists. It hits the database immediately and returns null if there is no matching row. And third one is save method to save the object. And fourth one is save or update method. Update or save an object. And fifth one is delete method. Delete an object and make it transient again. And eighth one is JMS, Java Messaging Service. JMS. It's an important component in advanced Java programming that enables efficient communication between various software components using a messaging model. It facilitates the functionality to exchange the information without need of direct or immediate interaction. Components do not need on each other's availability. JMS is built on the concept of a messaging system where components can send and receive messages. This operates independently. P2P communication, messages are being sent from one producer to one consumer. Each message is consumed by only one consumer. JMS enables asynchronous communications to provide decoupling where components can communicate with each other and promotes loose coupling. And next one is Java security. The term security means to ensure that your application is secured and it checks for valid users if they log in. It may log in successfully if the user is authorized, but if the user is invalid, then it is denied access to the application. So basically, it works on 2 scenarios, that is authentication and authorization. It's a good practice that is designed to enhance the security of Java applications and the Java runtime environment. Java supports secure communication through protocols like SSL, TLS that enables encrypted data exchange over the network. Java application implements various authentication methods such as username, password, tokens, etc. You can understand JSON as a data text format. You may be wondering what are tokens. To put it simply, a token is a string of data that represents something else such as an entity. In the case of authentication, a non-JWT based token is a string of characters that allows the receiver to validate the sender's identity. When we create REST controllers where every method is independent, no session management or single sign-on SSO, and manage authorization to control access to specific functionalities. So these are the advanced Java. So this is the first we see about the Java, and then later we see about the advanced Java. Now we discuss about what is the difference between core Java and advanced Java. Advanced Java. In core Java, it covers the basic fundamentals of the Java programming language and makes your foundation strong, including syntax, data types, and basic programming constructs. In advanced Java, it covers technologies like JSP and servlet for creating dynamic web applications. And then second point, in core Java is the object-oriented programming, OOPS, that emphasizes class, object, inheritance, and encapsulation. In advanced Java, it introduced its frameworks like Spring and Hibernate. Next, third point in core Java. Core Java establishes some basic libraries like java.language, package, string manipulation, and exception handling for the basic operations. In advanced Java, it establishes Java database connectivity, JDBC, for interacting with the databases. And then fourth one is, in core Java, it introduced multi-threading that includes the creation of thread and basic synchronization. In advanced Java, uses technologies like SOAP and REST for creating and consuming web services. In fifth point, in core Java, it handles exceptions by using try-catch blocks as well as you can create custom exceptions. In advanced Java, uses design patterns that create well-structured and maintainable code. Okay, this is the difference between the Java and advanced Java. Here now we see about the just basics of advanced Java programming. In next module, we see about the components of advanced Java programming one by one. Thank you.